Hi friends, in this video we see 50 most expected questions that can be asked in Tneb exam from electromagnetic subject. The first question is, if force on a 10 coulomb due to 5 coulomb is 5 AY Newton, right? So here they told we have a 10 coulomb and 5 coulomb. Force on 10 coulomb due to 5 coulomb is 5 AY. Okay, this is the question. The force on 5 coulomb due to 10 coulomb, right? So now the question is, how much force acts on 5 coulomb due to 10 coulomb? We know as per Coulomb's law, force on charge 1 due to 2 is equal to minus force on charge 2 due to 1. That means both the forces are acting exactly opposite to each other. So this force on 10 due to 5 acting on y direction. So the force on 5 due to 10 coulomb should act in the opposite, that is minus y direction. Okay, next. For steady state condition, what is this? They are given continuity equation. So delta J is nothing but continuity equation. So for steady state condition, first we know what is continuity equation. Delta J is equal to minus dou rho V by dou T. And they are telling it is steady state. Steady state means the rate of change of charge is constant, so it will become 0, right? So rho v will become 0 constant, so dou by dou t will become 0, so delta J is equal to 0, right? Rho v is charge density. Under steady state condition, rho v is constant, so delta J is equal to 0. Next question. The flux of 10 Weber increasing to 20 Weber, right? So phi is increasing from 10 to 20 Weber in 2 seconds. What is flux change? Flux change is nothing but rate of change of flux with respect to time. So flux change is nothing but 10 increase from 10 to 20. So change in flux is 20 minus 10 per 2 seconds. So change in this one is given by, for 2 seconds it is 10 by 2. So for 1 second it is 5 Weber per second. So option B is the right answer, right? So d phi by dt, rate of change of flux per change in second, right? So 2 seconds it is changing to 10. So 1 second it is changing to 5. Okay. Next one, when a magnetic flux cuts across n turns, that is 100 turns, n is equal to 100 turns at the rate of flux 5 Weber per second, right? Flux density. So d phi by dt is equal to 5 Weber per second. What is induced EMF? Induced EMF V EMF is equal to n d phi by dt. So 100 into 5, so 500 volt. So option D is the right answer. Okay, next question is, if the magnetic flux of 20 Weber passes through an area of 2 meters square, what is the flux density? Flux density is given by flux per unit area. Flux density is flux per area. Population density is population per area. Flux density is flux per area. Flux is 20 milliweber. Area is 2 meters squared. So 10, right, milliweber per meter squared. So option B is the right answer. Next question. A 1 meter long conductor carries a current of, so first length is 1 meter, current is 10 ampere, and angle is theta degree. B is 2 Weber per meter square. What is the magnitude of force? Force is equal to BIL, right, sin theta. Yes or no? So force is equal to BIL sin theta. So what is B? B is 2 Weber per meter, I is 10 ampere, L is 1 meter. So this current I is equal to 10 ampere, right? BL sine 30 degrees, sine 30 is 1 by 2. So 20 into 1 by 2, it is 10 Newton. So option A is the right answer. Fine? Okay. Next one. A 50 ohm transmission line is terminated by 50 ohm load. So this is transmission line. The line impedance is 50. That is characteristic impedance is 50. It is terminated by 50 ohm load. What is the input impedance? We know when line impedance is matched to this one characteristic impedance, input impedance equal to Z0. So what is my input impedance? That is equal to Z0, that is 50 ohm. That is the condition. So option C is the right answer. Next one. Okay. If the dimensions of the narrow and broad walls of a waveguide are 2 cm and 3 cm. Narrow wall dimension is 2 cm, broad wall 3 cm. What is the cutoff wavelength? Cutoff wavelength for dominant mode. Cutoff wavelength for dominant mode is 2 the dimension of broad wall. So it is 2 into 3, 6 cm. Fine. So the answer is option B. Okay. The velocity of an EM wave in a medium with epsilon r3, mu r is equal to 3. Velocity in medium is given by 1 by root of mu epsilon. That is given by 1 by root of mu naught epsilon naught mu r epsilon r. Because mu is equal to mu naught mu r, epsilon is equal to epsilon r. So that I can write as 1 by mu naught epsilon naught mu r epsilon r. 1 by mu naught epsilon naught is equal to 3 into 10 power 8 divided by root of 3 into 3. So 3 will come outside. So 3 into 3, root 9 is 3. So 3 by 3 is 1. So 1 into 10 power 8 meter per second. So 1, sorry, 1 into 10 power 8 meter per second. Next one, the current in an inductor changes from 10 to 20 milliampere, right, in 2 seconds. The rate of change of current, right? So current in inductor changes. So rate of change of current they are asking. So what is rate of change of current? In 2 seconds, current changes to 10 milliampere because 10 to 20 it is changing. So in 1 second, it is 5 milli, right? So 5 milliampere per second, right? So the answer is 5 milliampere per second. Simple problem. 11th one, the inductance of a coil which induces voltage of 10 volt at the rate of change of current is 2 ampere per second, right? So di by dt, rate of change of current, it is rate of change of current is 2 ampere per second. They are asking about L. So we know V is equal to L di by dt. So this implies L is equal to V by di by dt. V is 10 volt, this is 2, so 5 and 3. So option D is a right answer. Next one, the induced voltage produced across a inductance of L, they have given 10 Henry by a current 10 ampere per 2 second. So they are given I is equal to di by dt or I is equal to 10 ampere per 2 second. This is 5 ampere per second. So what they ask is induced voltage. So induced voltage is V is equal to L di by dt. L is 10, di by dt is 5, so 50 volt. Right? So option B is the right answer. Clear? Okay. Next one. The current density of a material with conductivity 20 into 10 power 6. Conductivity they have given 20 into 10 power 6. And electric field 2 volt per meter. What is current density? J is equal to sigma E. So that is 40 into 10 power 6, right? Ampere per meter square, right? So this is J sigma is 20, this one is 40, so 40 into 10 power 6. I think they have given 40 in 10 power 7, it must be 6, then only it must be the correct answer. So the answer is option C. Okay. The charge stored in a 10 microfarad capacitor, C is equal to 10 microfarad with the voltage is 20 volt. What is the charge stored? Q is equal to C into V, 10 into 10 power minus 6 into 20 volt. Right? So that is how many? 200, that is 10 power minus 3 Coulomb. That is 1 millicoulomb. Fine. Oh, this is 10 power 10 into this 10 into 200. Okay, this is 200. 200 means 2 into, okay, sorry, 200 into 10 power minus 6. This is 2 into 10 power minus 4. It is nothing but 0.2 millicoulomb. Fine. So 2 into 10 power minus 4 is nothing but 0.2 into 10 power minus 3 coulomb. So 0.2 millicoulomb. Okay, fine. The next one, the charge stored in a capacitor when a constant current of 10 microfarad, I is equal to 10 microampere, flows in 5 seconds. dt is equal to 5 seconds. What is the question they are asking? The charge stored Q, right? We know I is equal to dq by dt. So Q is equal to I into dt. I is 10 microampere. A is 5. So 50 microcoulomb. Ampere per second is coulomb. So it is 50 microcoulomb. Right? Okay. Next question is the voltage across a capacitor of 100 microfarad, C is equal to, 10 microfarad, when a constant current of I is equal to 5 milliampere flows in 1 second, right? So they are asking about voltage. So in capacitor we know I is equal to C dV by dt. This implies I is constant, C is 10 microfarad, so that is dV is constant, so V by T I can write, so V by T is 1. This implies V is equal to 5 milliampere, so 5 into 10 power minus 3, 10 microfarad, it is nothing but 10 power minus 5, so that is equal to 500 volt. So option C is the right answer. Next one, if the flux passing through a cube is 50 microcoulomb. So pi is equal to 50 microcoulomb. The total charge, okay, flux is 50 microcoulomb, pi is 50 microcoulomb. The total charge enclosed by a cube. The cube's dimension is given. X varies from 0 to 1, y varies from 0 to 1, z varies to 0 to 1. But as per Gauss law, what is the question they are asking? The charge enclosed. The charge enclosed is We know as per charge law, d dot ds is equal to q enclosed. Right? The electric flux passing through, that is equal to pi e. The electric flux passing through any closed surface is equal to charge enclosed. So here 50 microcoulomb is passing through the closed surface. So the charge enclosed is 50 microcoulomb because flux is nothing but charge enclosed. Okay, option C is the right answer. Next one, in free space E is equal to 3 volt per meter. Then H is, we know in free space E by H is equal to 120 pi, that is eta. So this implies 3 by H is equal to 120 pi. So H is equal to 3 by 120 pi 1 by 40 pi, right? Ampere per meter. Okay. Next one, if a medium has sigma is equal to 10 power minus 2 mho per meter, mu r1, epsilon r1 and f is equal to 50 hertz, we have to check whether this is conductor or semiconductor or dielectric. So for that we have to check the ratio of sigma by omega epsilon. Sigma is 10 power minus 2, omega is 2 pi f 50. Epsilon is, I can write as 1 by 36 pi into 10 power minus 9. If it is coming up, let us assume this will be small value, small by small, very small value, right? But 10 power minus 9, it comes up, it will become 10 power 9. Even though it is very small, it will be far greater than 1. Since sigma by omega epsilon is far greater than 1, it is good conductor. So the answer is option A. If sigma by omega epsilon is less than 1, it is dielectric medium. Fine, okay. Next one, in a charge-free region, what is delta D? Don't confuse, delta D is not rho v. Charge-free region means there is no charge. So there is no charge. Q0 means rho v 0. This implies, as per Gauss law, delta D is equal to 0. Option D is right answer. Please remember. The law which deals with the time varying field, you know, Gauss law is not dealing with the time because delta D is equal to rho v. Ampere circuital law, del cross H is equal to J. Del cross Biot-Savat law, Faraday's law, del cross E is equal to minus dou v by dou t. First person who bring time into the field concept is Faraday only. Ampere circuit law, we know H is equal to IDL by 4 pi r square AR. So Faraday is the first person who brought the term time varying field. So Faraday's law deals with the time varying field out of these 4. Okay, 1 dB is, this is decibel. In dB, in terms of power, it is 10 log P2 by P1 or 20 log V2 by V1. So here we have 10 log V2 by V1. This is wrong. This is wrong. This is wrong. This is right. Okay. So 10 log P2 by B1 is right. Next one, the wavelength of a wave with propagation constant. Gamma is equal to 0.1 pi plus j 0.2 pi. This indicates alpha is 0.1 pi because that is gamma is equal to alpha plus j beta. Beta is equal to 0.2 pi. So what I have to find? Gamma, right? So I have to find the wavelength. Wavelength is equal to 2 pi by beta. So 2 pi by 0.2 pi is 10 meter. So wavelength is 10 meter. Option A is the right answer. Alpha is attenuation, beta is phase constant. Fine. Okay. Next question is, so for a lossless medium with epsilon r is equal to 1, mu r is equal to 4, the impedance. So we know impedance eta is equal to root of mu by epsilon. So that is equal to mu naught mu r divided by epsilon naught epsilon r. right? So mu naught by epsilon naught divided into mu r. This mu naught by epsilon naught is 377 ohm. Mu r is 4, epsilon r is 1. So root 4 is 2, so that is equal to 754 ohm. So option B is the right answer. Next question, if a line charge of 1 picocoulomb is distributed along this z-axis, so rho L is 1 picocoulomb. Right, from minus infinity to plus infinity, the electric field on the curved surface of the cylinder whose radius is 1 centimeter. So rho is 1 centimeter. What is the thing? Electric field due to line charge. They are asking the electric field, right? So the electric field line charge. So electric field due to line charge is given by E is equal to rho L by 2 pi epsilon rho. So rho L is 1 into 10 power minus. R is 1 centimeter. Is 10 power minus 2. Okay. So 2 pi is free space, 2 pi epsilon naught. We know 1 by 4 pi epsilon naught is equal to 9 into 10 power 9. So 1 by 2 pi epsilon naught is 2 into 10 power 2 into 10 power 9. Okay. So what will happen? This is becoming 1 into, this is 2 into 10 power 9. Fine. Okay. Rho L is 1 picocoulomb 2. Okay. Well, so this is what do you call? What is the question? Rho L by 2 pi. Okay. So 2 into 10 power 9. Sorry, 2 into 9, right? Into 9 into 10 power 9, right? Because you see 1 by 4 by epsilon naught is 9 into 10 power 9. 2 into 1 by 4 pi epsilon naught is equal to 1 by 2 pi epsilon 9. That is 2 into 9, 10 power 9. So this is giving, it is 18. So 18 into 10 power minus 12. Find 1 centimeter. It is 10 power 11. Okay. So this is giving what you call, this is 1 centimeter, right? So 1 centimeter is 1 into 10 power minus 18 into 10 power minus 1.8. 1.8 volt per meter. Okay. So that is the answer. So oil is here oil is 1 pico, 1 into 10 power minus 12. 1 by 2 by epsilon naught is 2 into 9, 10 power 9. So 18 into 10 power 9, 10 power minus 12. Fine. Okay, this is giving 10 power minus 12 coming up 10 power 11. So it is 1.18 into 10 power minus 1. So 1.8 volt. Okay. Next one, if D is equal to 6y Coulomb per meter square, the flux crossing 1 meter square area. I don't mind about all the things. They are talking about the flux crossing. So flux they are asking. D is nothing but flux density. Flux density is nothing but flux per area. Flux per area is 6. Magnitude only you take, don't mind about other area. So flux per area is 6. Area is 1. So this implies flux is equal to 6. Flux is nothing but Q enclosed. So 6 Coulomb. Right? As per Gauss law, flux is nothing but Q enclosed. Because the electric flux passing through any closed surface is equal to charge enclosed. That is what Gauss law. So it is 6 Coulomb. Right. Two infinite sheets with charge rho s on each side are located at x is equal to plus or minus 3 meters. So let us assume here x, okay, minus x, two charges located, this sheet is located at plus 3, this sheet is located at minus 3. We know that A is rho s by 2 epsilon naught n cap. So electric field will be perpendicular to the sheet, so this field will go this side, right? Similarly, this field will go this minus 10. What is the electric field in between minus 2 to plus 2? They are asking. In between the minus 2 to plus 2, electric field is 0. That is my electric field. Electric field is normal to the sheet, so this will go this side, this will go this side. Okay, so the answer is okay. In a charge-free region, Ex equal to 3x, Ey is equal to 3y. What is Ez? Charge-free region means total field must be 0. That is, magnitude of the field must be 0. So it is 3, it is 3. So 3 plus 3 is 6. So in z direction, it should be minus. Right? So what will be the answer? The answer is it will be minus 6, right? So total will be minus 6 because it is 3 plus 3 is 6, so that should be nullified. So the electric field should have minus 6z. So that is my answer. So it must be minus 6. So the answer is minus 6, not plus 6. So you must be careful. I have to nullify this. So in charge-free region, total component should be equal to 0. Gain of an antenna is measured with respect to isotropic antenna. So the well-known direct question. Next one, 1 milliwatt is equal to in dBm. Right? So we know power in dBm is given by 10 log, right, P milliwatt. So they are giving power, watt W is there, so it is power in dBm divided by 1 milliwatt. It is dBm is nothing but power measured with respect to milliwatt. So 10 log power is 1 milliwatt divided by watt, that is equal to 0. Log 1 is 0. The answer is 0 dBm. Fine? Okay. So the next question is, a load impedance of 200 plus J0 ohm is to be matched to a 50 ohm lossless transmission line by using quarter wave transformer. QWT is quarter wave transformer. The characteristics impedance of the quarter wave transformer. This is what they are asking. So we know for quarter wave transformer, Z0 squared is equal to Zin into ZL. So load impedance they have given, characteristics impedance they have given. Z0 is 50 ohm, ZL is 200 ohm. J0, right? No problem. So what they ask, they have given load impedance ZL 200 characteristics. So we have to find, okay, transfer line using a load impedance 50 ohm lossless line, right? So ZL given. So what we have to find the input impedance. So we have to find load impedance this one, and why they are asking this confusion matched to a okay, input is load, this is load, this is in, right? So Z0 squared we have to find. So it is matched to 50 ohm. So this is considered to be input impedance. So 50 into 200. So Z0 is equal to 100 ohm. Okay. Next question. A lossless transmission line having characteristics impedance 50 ohm. So, okay, characteristics Z0 is equal to 50 ohm. And, okay, let us read the question first. Length of lambda by 4 is short circuited at one end. So, length is lambda by 4, short circuited at one end and connected to a voltage source of 1 volt at the other end. What is the current drawn from the source? Okay, so this is the question. So, what they have given, a line with 50 ohm characteristics impedance, right? The length is lambda by 4. It connected to a one end short circuited. One end is short circuited and connected to a voltage source of 1 volt at the other end. What is the current drawn from the source? So what is the I value they are asking? So lambda by 4 length, so it is quarter wave transformer. So for that input impedance, I need I is equal to V in by Z in. So I want Z in. Zn is equal to Z0 square by ZL. Load is shorted, so Z0 squared by 0, right? So Zn is infinity, right? So Zn is infinity means what about I? I is equal to V by V in by Zn, 1 by infinity 0. So the answer is option A. Okay, next question. One end of a transmission line having a characteristics impedance of 75 ohm and length of 1 centimeter is short circuited at 3 gigahertz. The input impedance is at the other end of the line, right? So this is what they are asking. Let us solve this problem. What is the input impedance at the other end? Okay. So we have to find whether it is capacitive, resistive or inductive. Okay. So as per the problem, what we have to know, we know that what are the data given? Characteristic impedance 75 ohm. So Z0 75 ohm. Then they have given length is equal to 1 centimeter, that is 10 power minus 2 meter. Frequency 3 gigahertz. They are asking Z in value, right? So the circuit is short circuit line. Okay, right? So we know that for short circuit line Zn, it is what about this line? It is lossless. Yes, lossless also. For lossless short circuit line, Zn is equal to JZ0 tan beta L, right? So I want Z0, I have 75 ohm, J no problem, beta I have to find. Beta L is equal to 2 pi by lambda into L. Lambda is equal to C by F. 3 into 10 power 8 divided by 3 gigahertz. 3 into 10 power 9, it is 1 by 10 meter. So what about beta L? Beta L is equal to 2 pi by 1 by 10 will become 10. This is 1 centimeter. 1 centimeter is 1 by 100. So 2 pi into 1 by 100, it is 1 by 10, that is pi by 5. So beta L is equal to pi by 5. Now we got everything. So Zin is equal to J. Z0 is 75 tan pi by 5. So they are asking only the nature of the input impedance. It is resistive, capacitive or inductive. Since it is positive value, positive J, it is inductive reactance. So the answer is option, this is C, inductive. Okay. Next question is, the Vmax and Vminimum are 4 and 1 respectively. The value of reflection coefficient, right? So this is another simple question they are asking. What is that reflection coefficient I can get from Vmax and Vmin? So reflection coefficient is S minus 1 divided by S plus 1. S is Vmax by Vmin. So Vmax is 4, Vminimum is 1, so S is 4. So gamma is equal to 4 minus 1 divided by 4 plus 1, that is 3 by 5.6, right? Okay. And the next question is, the characteristics impedance of a transmission line is 50 ohm. So Z0 is 50 ohm. Input impedance of the open circuit line, right? So input impedance of open circuit line is 100 plus J150 ohm. When the transmission line is short circuited, what is the value of impedance? So short circuit impedance they are asking. So we know ZO is equal to ZOC and ZSC. This implies ZSC I want ZO squared by ZOC. ZO squared is 50 square divided by 100 plus J150. If you simplify, it will be 50 I take outside, so 2 plus J3. I multiply and divide by 2 minus J3. Take complex conjugate, 2 minus J3. 2 minus J3. If you simplify, what you get is 7.69 minus J 11.54, right? So this is question number 35. Okay, next question is, so the question is, a parabolic dish antenna has a beam width of 2 degree wide. The directivity of the antenna is approximately what? They are asking. So directivity of dish antenna is given by D is equal to 41253 divided by bandwidth in theta plane multiplied by bandwidth in pi plane, right? So 3 dB bandwidth is 2 degree they have given, right? Parabolic dish antenna has a beam width, not bandwidth, it is beam width. So 41253 divided by 2 into 2. So it is approximately, what we get is 10,000, which is approximately equal to 40 dB. So the answer is 40 dB. Okay. Next, a transmitting antenna radiates 251 watts isotropically. A receiving antenna located 100 meter away from the transmitting antenna has an effective aperture of 500 centimeters square. What is the total power received by the antenna, right? So what is the power transmitted by the antenna? Power transmitted by antenna is 251 watts. Distance between the two antenna is 100 meter. Okay, effective aperture area A is 500 centimeters square, that is 500 into 10 power minus 4. Don't forget it is centimeter square. So 10 power minus 4 meters square, right? What is the power received? Power received is given by, right, power transmitted divided by 4 pi r squared into AE, right? So power transmitted is, we know 251 watts. 4 pi r is nothing but distance. 100 square AE is 500 into 10 power minus 4. If we simplify, what we get is 100 microwatts. So the answer is 100 microwatts. Okay. Next question is, the off power beam width of an antenna in the two orthogonal planes are 100 degree and 60 degree, right? So two orthogonal planes are what? Theta and phi. So off power beam with 3 dB is 100 degree, in pi 3 dB is 60 degree. What is the directivity? So they are given off power beamwidth. So directivity is given by, we know it is 41,200 divided by theta 3 dB pi 3 dB. That is equal to 41,200 divided by 100 into 60, right? So D is approximately equal to, so 3 is equal to, what you call, if you take 3, it will be 6.85, which is approximately equal to 8 dB. So the option B is the right answer. Okay. Next one is, at 20 gigahertz, the gain of the parabolic dish antenna of 1 meter diameter and 70% efficiency is, right? Okay, so it is parabolic dish antenna. F is equal to 20 gigahertz, diameter 1 meter, efficiency is 70%, right? They are asking about gain. Gain of the parabolic dish antenna is given by G is equal to eta pi into pi squared by into D by lambda whole square. Eta is 70%, so 0.7 pi square. D is diameter 1. Lambda is C by F. C is 3 into 10 power 8. F is 20 into 10 power 9. So if you simplify, what we get is approximately in dB 45 dB. So the answer is 45 dB. Okay. And the next question is, a wave is totally reflected when medium 1 is denser than medium 2. Okay. Fine. Next. The question is, the electric field E is said to be conservative. A field is called conservative if del cross E is equal to 0. Yes or no? Right? The path is, the field is independent of path. Fork done is independent of path. Here, where is del cross E? It is not there. It is not there. It is del cross E. It is not there. But here we have E dot dl. See, the integral form of E dot dl is, the integral form of del cross E0 is E dot dl, right? So it indicates curl of electric field is 0. So the answer is option D. Next one, a metal sphere with 1 meter radius and surface charge density of 10 Coulomb per meter square is enclosed in a cube of surface charge 10 Coulomb, cube of side 10 meter, right? Okay, next, the total outward electric displacement normal to the surface of the cube, right? So here you see the metal sphere with 1 meter radius, surface charge density is enclosed in a cube. So we have a cube like this, right? Inside this we have a one metal sphere of radius 1 meter, right? Cube side is 10 meter. This is 10 meter, this is 10 meter. The outward electric displacement, right? So the sphere is enclosed in a cube, right? As per the Gauss law, the flux displaced is equal to the charge enclosed. So we know that d dot ds is equal to q enclosed. What they have given? 10 Coulomb per meter square they have given. So rho s they have given 10 Coulomb per meter square. Since it is 10 Coulomb per meter square, it is surface charge density, right? So as per this 10 Coulomb per meter square, d dot ds is the flux displacement. Fine. So integral d dot ds is total flux displacement through the enclosed surface. So q only is equal, in the formula we have only q, but we have rho s. How can we relate? Q is equal to rho s into area. What is that? Q is charge. Charge is equal to rho s is charge per meter square into meter square area. So rho s is charge density area. Charge density they have given 10. Area is, it is a sphere. Sphere surface area is 4 pi r square. But radius of the sphere is 1. So 10 into 4 pi, 40 pi coulombs. So the answer is option A. Okay. Next question, the time averaged Poynting vector for a wave of E is equal to this one in free space. Okay, so they ask time average Poynting vector. Time average Poynting vector P average is given by what you call E squared by 2 eta. Fine, magnitude. So what we have to find, E is they have given 24 square by 2, eta is 120 pi, 120 pi. So it is 24, so 1 by, 2.4, 24 into 24 divided by 240. So it will become 2.4 divided by pi watt per meter square. In vector form, how can we find this scalar form? In vector form, P average, this is scalar, E squared by 2 eta. In scalar, how can we find P average is equal, in vector it is minus 2.4 pi AZ watt per meter square. Why I put minus? Here you see, as per the problem, the wave is propagating in minus z direction. Omega t minus plus minus beta z means it will be plus direction. Since it is given plus, so it is traveling in minus z direction. So power will flow on the same direction. So I have to put minus 2.4 by pi. If they give plus 2.4 by pi, that option is wrong. Please choose it is minus 2.4 by pi. Okay. An electric field defined by V is equal to 20 R power minus 1 plus R power minus 2, where R is the distance from the source to the field, is due to monopole, dipole, both are none. So we know in potential due to point charge is inversely proportional to R. Potential due to dipole is inversely proportional to R square. So it is 20 1 by R plus 1 by R square. So it is point charge means monopole, single charge, 1 by R square dipole. So it has both R power minus 1 and R power minus 2. So it includes the potential is created by both monopole and dipole. If potential is created by both monopole and dipole means electric field is also created by monopole and dipole. So the answer is option C. Next one, the depth of penetration of an EM wave in a medium with sigma is equal to 5.8 into 10 power 7, mu r is equal to 1, epsilon r is equal to 1, at f is equal to 100 megahertz. So we know depth of penetration or skin depth is given by del is equal to root of 1 by pi f mu sigma. So 1 by pi f is equal to 10 power 7, 10 megahertz. Mu is mu naught mu r. Mu naught is nothing but 4 pi into 10 power 7. Conductivity is 5.8 into 10 power 7. So it is equal to 6.08 into 10 power minus 6 meter. Simple problem. Okay. The next question is the electric field just above the conductor. The electric field just above the conductor is normal to the conductor surface. Inside the conductor, electric field is 0, right? So that is a very, very important point. So next question is, if magnetic field H is equal to 28x AX, what is current density? We know current density J is equal to del cross H. So I have to find del cross H. AX, AY, AZ, dou by dou X, dou by dou Y, dou by dou Z. This is given by 0, 28 sin X, 0. So if I simplify, what I get is, here if I take this one, minus plus minus plus plus minus plus minus, so minus 28 sin X. If I take this one, we have to multiply this one and this one. So it is what do you call? Okay, otherwise I simplify like this. If I simplify, if I take AX, it will be dou by dou Z 28 sin X, 0. Fine. If I take AY, 0. If I take AZ, dou by dou X 28 sin X, so that is equal to 28 cos X. So cos X AZ. So 28 cos Z cos X AZ. Okay. Next problem, if magnetic flux density B is equal to rho A rho, the total flux crossing the surface pi is equal to pi by 2 and rho is equal to 1 to 2 and Z varies between 0 to 5 meter. So if B is given, what is flux? Flux is equal to double integral B dot ds. B is given, ds we have to find. So B is in arrow direction. In arrow direction, what is ds? ds as per the cylindrical coordinate system, ds will be d rho dz arrow, right, in arrow direction. Okay, so it is arrow or a phi. Sorry, in question it is a phi is given. So I can write d rho dz a phi, right, in a phi direction. Okay, please change it. So what will happen? So now you take dot product. This is B is rho a phi dot d rho dz a phi. So what you get is, okay, I have no place. So this is rho, a phi 1, so d rho dz. So integration with respect to rho and z, rho varies from 1 to 2, z varies from 0 to 5. So if you simplify, what you get is rho squared by 2, 0 to 1, dz is z, 0 to 5. So 1 by 2 into, right, okay, this is rho squared by 2. So what we get is rho varies from 1 to 2, not 0 to 2. Rho varies from, you see, rho varies from 1 to 2. So 1 to 2, so rho squared by 2 is 2 by 2 squared by 2, 4 by 2, I erase it. 4 by 2 minus 1 by 2 into 5. So that is equal to 7.5. So the answer is 7.5 Weber. Next one, a point charge of 10 nanocoulomb is at origin. The potential difference at 1,0,0 with respect to 2,0,0. So potential difference between A and B. So let us take B is equal to KQ by R 1 by RA minus 1 by RB. So K is 9 into 10 power 9. Q is what is that? 10 nanocoulomb. So 10 into 10 power minus 9. Right? RA is distance from point A to origin. Origin is 0, 0, 0. This is 1, 1, 0, 0. So 1. This is distance from point B. This is point B to origin. So it is 1 by 2. 0, 0, 0 to 2, 0, 0. If you simplify, we will get 45 volt. Okay, the last question is the unit of Laplacian operator is del square. Del is 1 by m. So del square unit is 1 by m square. M square. Okay, I hope you understand all the problems. If you have any doubt, please ask me in comment section. I will clarify. Thank you.